Okay, today we are doing combining like terms. It's something that maybe you've seen before. It's relatively straightforward, but there are a couple of tricky things in there that we want to clear up as we go on. Now, I'm going to get to what this wagon train here thing means in a minute. But combining like terms is when you take terms of the same variable, you can put them together according to the sign in front. So let's look at this example here. 3x. Now we know from previous learning that 3x is multiplication because there's no sign. And what 3x means is there are 3 x's. X plus x plus x. It means 3 times x. 4x means, obviously, there are 4 x's. X plus x plus x plus x. When we talk about combining terms, we can combine the x's together to get 7x. It's just that simple. Now I like to use the wagon train example because think about the Oregon Trail. And this is going to come into, this is kind of a weird analogy, but it'll make maybe a little bit of sense as we move on. When the wagon trains went over the Oregon Trail, they all got all these wagons together, and a big group of people would go over on the Oregon Trail. And the families would have their own wagon trains. So what I like to think of it as I look at the terms of the variables as the families going in the wagon train. So let's say this is the Taylor family. The Taylor family is broken into the adults. There's 3 adults and 4 teenagers. They have their own wagons. The adults have 3 wagons. The teenagers have 4 wagons, but they're still the Taylor family. They're going on the Oregon Trail. The Taylor family has 7 wagons altogether. All right? Just think of that analogy as we move on. Maybe stupid to you, but I kind of like it. So another example, let's take another example. There's another family. Let's say this is the Smith family. All the kids have 10 wagons. There's 10 X's in the Smith family. The cousins have 3 wagons. There's 3 wagons on the Oregon Trail. And the grandparents have 3 wagons. But all the Smiths together as a family, you combine them. You have 10 X's or Smiths. You have 3 X's or Smiths. 3 more X's or Smiths. And you have 16 Smiths or X's altogether. So 16X going across on the wagon train. So that's how the wagon train thing works. But then, of course, when you get on the wagon train, people want to go to the Oregon Trail. But you know what? You get a lot of stragglers want to show up. People just show up. They don't have a wagon, but they want to go anyway. And we are going to let them come. We call them stragglers in our analogy. In the math thing, we're going to call them constants. The constants are numbers without letters. They don't have a family. They're just going along. They want company as they go along. Okay? Constants, or the stragglers, can also go along on the Oregon Trail. So let's look at our analogy again. The Taylor family has 6 wagons. The adults do. The kids have 4 wagons in this group. We're getting ready. We're to Kansas City. We're going to the Oregon Trail. And then we have a group of 5 strangers or stragglers. They want to come. And another group of 10 strangers and stragglers. They want to come to the Oregon Trail. So we all get together. The Taylor family has 10 wagons, or 10X, mathematically. The stragglers, although they come in 2 different groups, they're going to be in one group, and they're going to be a group of 15. We don't mind having the stragglers along, but they're always going to be at the end, and they don't get to be in the wagon. That's my analogy. The stragglers are at the end. They don't get to be in the wagons. They can come, but they cannot be in the wagons. All right, so we get confused about combining like terms. Families stay together, stragglers stay at the end. So another example, there's a wagon of 3 wagons, a group of 3 stragglers, and 9 stragglers. They can be combined. The 3x and the stragglers combined to be plus 12. We call the stragglers mathematically constants. We just use the straggler term as we kind of learn about all this. Okay? Video ID. Every video, there'll be you have to prove to me or your teacher that you have watched this video, and today's video ID is the 9 of clubs. 9 of clubs is this video ID. Now I'm going to get a little bit tougher here as we move on, so let's review again quickly. Combining like terms. There are 2 X's, 4 X's. They can go together for 6X. I call them families as far as the Oregon Trail analogy. We have down here a little bit tricky because I mixed them up. I've got 2x's here. I've got 4x's there. They go together to be 6x, and the stragglers or constants can come along and be with us. So that's 6x plus 3. And when we do math, you'll see this is a little bit longer. That's a little bit easier. That's why we combine terms to make your life easier. I'm going to throw a couple of our wrenches in here for you now. So now there are 4 terms we have. We have terms with some families, a family of r's. We have 4 r's and 2 r's. The stragglers, or the constants, are a group of 3 and a group of 4. We can combine the family and we can combine the constants, and we get 4 r's plus 2 r's is 6 r's. 3 plus 4 is plus 7. But now I'm going to throw a wrench into you at the family. So take a look closely at this one before I explain it. Take a look at all those terms, and you may notice something a little bit different. You should see that the letters are different. That means we have different families. It's key to remember the families cannot mix up. The families can go together on the Oregon Trail. They cannot mix up. And to help you remember that, I call the H family. There's 5 wagons of the H family. We're going to call them the Hatfields, the 5 Hatfields. There's 3 wagon train of the McCoys, the 3 McCoys. There's 4 stragglers want to come along. There's 5 more wagons of the McCoys, and there's 2 more wagons of stragglers. 2 more stragglers. So they can go together as a group along on the Oregon Trail, but the Hatfields and McCoys will never mix up. Okay, they're going to stay separate. So the Hatfields will be by themselves, 5 H's. The McCoys, they can combine these because they're the same family. They become 8 H's, or 8 M's, 8 M's. And the stragglers can combine and they become 6. So now we've added different kinds of families. The families combine, but they can't mix up families. Different families, stragglers, stay apart. So now we're almost done, and it's time to say goodbye to the analogy of the wagon train and the stragglers, because now we have thrown in negative numbers. And combining terms, the negative numbers matter. It's hard to do the analogy with that, so now I'm going to throw out the wagons and throw out the stragglers, and we're going to start using the mathematical terms for our last slide. So let's take a look up here. We have 5 x's is a term. We have 2 x's as a term. And we have a -3 as the constant. We can combine the families. We can combine the terms. So we have 5 and 2 is 7x, and the stragglers, or the constants, is -3. Looking at this one down here, we've got, let's take a look. We've got x's, we've got -3, we've got -2, and we have constants of +2 and +8. We can combine the x's. -3 plus -2 is a -5. We can combine the constants. 2 plus 8 is 10. And you would agree that this right here, -5x plus 10, is a lot easier to work with than all this stuff right here. And the last one, we've got 2 different sets of families and the constants. We have the s's. We have 4s. And way over here, we have +3s. That'd be 7 s's. And we look again, we have 4 t's, but be careful, warning, warning. -4t is being subtracted. So we subtract 4t. And we have families or constants of 2 and -6. 2 minus 6 is -4. So these examples here throw a little bit of everything in there. We have some negative numbers, and we have multiple terms that can be combined. Terms can only go with the terms that are alike. Different terms can go together. And this is an example of different terms going together, the 4 and the 3, along with the 4t. All right. Key points then are, these are the things to remember in combining like terms. Different terms or families cannot be combined. Different families cannot be combined. Same terms can. The s's can go together. The s's cannot go with the t. That's a key point. Next key point, the constants, stragglers for the last time, the constants can combine with constants, but not terms. Constants can go together, but not terms. The sign in front of the term or constant matters. Look at the sign in front. This minus sign is in front of the 4t. This minus sign is in front of the 3x. That matters. These three are the biggest mistakes will happen or misconceptions will happen with one of these three things, particularly the negative number stuff. And lastly, it's not really wrong, but it's just kind of the way we do things in math. It keeps things consistent for us. You put multiple terms in alphabetical order, and the constants always go at the end. So that's your combining like terms. These are your key points. And hold on to this, review this if you need to, and thanks a lot.